Hello and good day to everyone in attendance. We are your Entertainment Insights consulting team, and it's good to see you all here again. We'd like to thank Reed Hastings and the senior management team at Netflix for inviting us here today to present our project results and recommendations to the members of the executive board. We think that you'll be quite pleased with the results. This project enables Netflix to plan and execute in advance quality movie projects with a high probability of success at the outset, that is, before millions of dollars are put on the line. It enables Netflix to continue to hold the high ground. So let's get to work. Here's our agenda for today. As you can see, we'll begin with introductions of your consulting team from Entertainment Insights, and then we'll proceed to walk through the project and its goals, our extensive work with the data, our comprehensive model building, our findings, a demonstration of your new dashboard and related tool to help you with timely decision making, and finally, our recommendations for the way ahead. In essence, during today's meeting, we plan to answer the following big questions up front. What is the problem? How did we analyze it? What did we learn? And what do we recommend? We, of course, will be available after the meeting as well to answer any questions that you might have. So it's time to meet the team. Entertainment Insights is a Hollywood-based data science consulting firm specializing in analytics for the entertainment industry. Since we've completed a number of consulting projects with Netflix over the years, I'd like to introduce, or should I say reintroduce, your Entertainment Insights consulting team members in our primary roles for this project. Christian Caparelletti is our business intelligence expert and primary app designer. Chris Jones is our chief data engineer. Charles McGrath is our senior technical writer. Andrilla Sill is our chief data scientist, and yours truly, Ray Mountain, is the project manager. Let's take a look at the competitive landscape. While Netflix is a name synonymous with innovation in streaming movies on demand, today we find ourselves in a highly competitive and fragmented market. We are competing for viewer and subscriber attention as they are bombarded with offerings of varying quality from dozens of would-be rivals. Many of these contenders are multi-billion-dollar companies like ourselves, from both the tech and entertainment industries. Subscribers will of necessity, driven by simple economics, need to limit their choices to only 3 or 4 central streaming services. For the providers of these services, it is clear that only the strong, creative, and agile will be able to survive the coming shakeout and consolidation. In this environment, being identified as a reliable quality choice and a good value offers a huge competitive advantage. Being the top choice means your rivals need to fight for second and third place or risk being a casualty of the streaming wars. We want people to come home and habitually ask, hey, what's on Netflix tonight? Project goals and deliverables. In terms of our project goal, our mission is to provide Netflix internal stakeholders with tools to identify potential projects with high probabilities of critical success at the outset. For deliverables, we've developed a machine learning model that can predict the critical reception of a film given basic facts about the production. These include the director, writer, and actors involved with the film, as well as its language, genre, rating, and runtime, among other features. We believe that this will help the Netflix executives gauge the critical success of a film by inputting a series of data points known about the project at an early stage. We've also developed an exploratory tool, a dashboard with a related mobile access, informed by our predictive model, that allows the user to explore the impact of the company's creative decisions on a film's quality. We'll have more detail on this for you later in the presentation. Project timeline. Here you can see the 4 phases of our project, culminating with today's presentation of our model, findings, recommendation, and tools to help Netflix managers outperform the competition. As we have on each of our prior engagements with Netflix, every phase of this project with Entertainment Insights came in on time and on budget, just as you'd expect. I will now turn the presentation over to my colleague, Charles McGrath. Charles?
Data overview and sourcing. We base our target variable on Rotten Tomatoes Tomato Meter score. The score is created by the movie critic aggregator to measure a film's quality. Rotten Tomatoes collects data on the critical reception of movies, rating them on a scale from 0% to 100%, measured by the rate of positive reviews. Scores above 75% are certified fresh. Those between 75 and 60 are fresh, with anything below 60% as rated as rotten. The logic here is that the collective opinion of industry critics will confidently gauge a movie's quality. Our web scraping script was able to extract each movie's tomato meter score, release year, as well as number of critical reviews it received. The number of reviews it received will become important later in our final quality score target variable. Feature data. Our feature data was extracted from movie database website imdb.com and the Academy Awards database. Among the features we pulled from this site were names of writers, directors, and the cast, as well as month of release, runtime, and genre, as well as language, rating, and distributor. Using each movie's name from Rotten Tomatoes to search a separate site for corresponding data added another layer of difficulty. Many movies had similar names but could vary significantly in quality. For example, 2000's Best Picture Award Gladiator starring Russell Crowe had a Rotten Tomatoes score of 78, certified fresh, while 1992 Cuba Gooding Jr. film of the same name about Chicago's underground boxing scene was rated 31%. To mitigate this, we use each film's release year as an additional piece of verification before the scraper selected the correct IMDb page to collect from. Data scope. The initial scope of our web scraper focused on movies only released by Netflix. As such, we were able to find data on each of the 622 films the company produced between 2013 and 2022. Initial findings using our late gradient boosted machine model were promising, so we chose to expand that beyond Netflix produced movies. That expanded scope targeted a set of 6,000 possible titles released within the past 5 years. A list that would be filtered down and sampled to be added to the original 622 Netflix titles. From that list, films with less than 20 reviews, up from 5 in the first set, were filtered out to remove obscure movies and restrict the set to feature films. Short films and documentaries were also filtered out from the data, again to keep the theme of feature films. From here, an additional list of films was pared down to 2,500 titles. That number was still too large for a scraper to feasibly extract the needed data points in a timely fashion. Not only did the scraper have to visit each movie's page in IMDb, but also those of the cast and crew. So a randomly selected sample of 750 movies was chosen from that list. The end data set consisted of just over 1,000 movies.
Thanks, Charlie. My name is Chris. I was the data engineer on the project. After collecting all the raw data, extensive work was done to derive various feature variables that we hypothesized would increase the predictive power of our model. The first variable we had to engineer was our target variable for movie quality. As Charlie mentioned earlier, we identified 2 data points as the inputs for our movie quality formula: the rate of positive reviews, or the tomato meter score, and the count of reviews. The easiest way to combine these numbers would have been to simply multiply them together, but that would have given too much weight to the review count, pushing blockbuster films of varying quality to the top of the list while disadvantaging independent films seen by fewer people. After several iterations, we came up with a highlighted formula, which multiplies the square of the tomato meter score by the square root of the review count. This produced a list of films sorted by quality that appropriately balanced the 2 input variables and best resembled the kind of quality we were looking for. At the top of the list are films that were both widely seen and very well reviewed. 4 of the films are Oscar nominees, including The Irishman and Roma, which received a combined 20 nominations. The number 1 film, Mission Impossible Fallout, is the only one not recognized by the Oscars. However, it was extraordinarily well received, with 97% of 439 critics evaluating it positively. Though unexpected, its status as the number 1 film did not undermine our confidence in this metric, as Netflix's drive for quality was never restricted to Oscar contenders. On the other end of the spectrum are the films in the table below, which displays the worst rated films with 50 or more reviews. In contrast to the best films, none of these films received any sought-after award. Instead, 3 of them were nominated for Razzies, or starred actors whose performances were. Virtually all critics agreed that these movies were better off unseen. The formula to the left produced this ranking of films, but to produce a metric ranging from 0 to 1, the resulting quality scores were normalized. Moreover, to get a roughly normal distribution, In line with our view of how quality is distributed in cinema, a square root transformation was applied. This resulted in the quality score values you see in the right column. This formula was not only used to generate our target variable, but it was also used to calculate quality metrics for cast and crew, as we'll explain in the next few slides. Our dataset consisted of thousands of actors, writers, and directors. In theory, a large enough model could have determined the impact of each individual on the film's critical reception, but with only 1,003 observations, this was not going to be possible. As a result, we took upon ourselves the task of quantifying the quality of each cast and crew member, or to be more precise, we quantified their propensity to be involved in quality films. This motivated our collection of each cast and crew member's recent films. In the case of directors, their output is limited by the fact that directing a film takes anywhere from 1 to several years. Thus, a time horizon that would fairly represent their recent output needs to last longer than 10 years. We settled on 20 years for directors to get a good sample of their recent work. Longer than that, and we risked inaccurately assessing the current abilities of a filmmaker. The next step was to assess the quality of each film. For this, we applied the same formula and transformations described in the previous slide. With these quality scores, we could simply take the average of a director's recent films and come up with a representation of the director's average quality. One problem with this implementation is that a director who just debuted with a well-received film may receive the same score as a director who has made 10 films of the same level of quality. This would not make sense, as someone who has made 10 consecutive quality films would be considered more reliable than someone who has only done so once. As a result, we divided by the square root of the number of films rather than just dividing by the number of films. This had the effect of decreasing the value of the denominator as n increased, relative to a simple average. Thus, a filmmaker with multiple great films received a better score than a director with only one. As was done for the movie quality scores, the output of this formula was normalized so that quality scores ranged from 0 to 1. Applying this formula produced the top 5 directors on the right. Even non-cinephiles would likely recognize the names of each of these individuals and associate them with quality. In some cases, films were co-directed by 2 or more directors. In such a situation, an average director quality was calculated based on the quality scores for each director. This was the variable used in our final model. Writer quality was determined using the same method. As you can see on the right, there are some recurring faces among the top writers. Joel Cohen and Richard Linklater also made the list of top directors. In fact, each of these writers is also a highly respected director, contributing to our conviction that writer-directors may have a stronger proclivity for producing quality films than non-writer directors. We'll evaluate the evidence for this belief later in our results. As we did for directors, when a film was written by 2 or more individuals, we took the average score of the writers, producing the writer quality metric that was used in our modeling. Actor quality was calculated similarly to director and writer quality, but there were a couple key differences. First, because actors are much more prolific, we based our quality scores on only films the actor appeared in during the 10 years prior to the release of the film in our dataset. Second, we included a movie age variable in the actor quality formula, so that films made 1 year ago counted more than films made 10 years ago. Dividing by this number unaltered produced scores that were too biased against older films, but some experimentation indicated that dividing by the cube root of this number generated the proper amount of discounting of age. In theory, this same discounting factor could be applied to writers and directors. Doing so, however, did not improve our ability to differentiate top quality films from the rest, at least not to the same extent that we found for actors. So this variable was omitted from the other formulas. The actor quality formula produced the following top 5 actors. Each of them is a household name recognized for his or her acting abilities. Almost all of them, in fact, have been nominated for an Oscar. An important reminder, though, is that our quality scores more accurately represent the quality of an individual's filmography. So actor quality scores are a dual measure of an actor's ability as well as the actor's choosiness when it comes to their projects. As we did for writers and directors, we averaged the quality scores of the first 5 actors listed on each film, producing a cast quality metric used in our model. We also engineered a few other variables that were more straightforward. First, for each director, writer, and cast, we calculated the number of previous Oscar nominations relevant to that particular role. For example, we tallied the number of past nominations for Best Director, Best Picture, and several other categories to determine the number of director-relevant nominations for a given director. In our dataset, the most decorated director by that measure was Steven Spielberg, with 10 such nominations. We applied the same methodology to writers and actors using the data provided in the Academy Awards database. We also created a binary variable for writer-directors, also known as auteurs, indicating when a film's director was also one of its writers. Finally, we created two binary variables indicating whether a movie was based on a true story or based on existing material. This was derived from the plot keywords listed on IMDb for each film. These keywords were found to consistently reference a film's source material if it had any, so we were able to reliably infer this information from these keywords. Because of our data collection process, which consisted of web scraping from websites with very structured data, there was little pre-processing work that had to be done outside of standardizing variables and the aforementioned data transformations. There were, however, a number of null quality scores for cast and crew members who had limited or no previous film experience. These were actually not cases of missing data, but cases of unknown quality. Some attempts to impute these values did not yield satisfying results, so we simply assigned a value of -1 to each null value in order to distinguish them from the range of plausible values. We also selected machine learning algorithms in our modeling that were capable of handling null values, which we'll discuss in more detail later. Now over to Andrilla, who will dive into our results and modeling.
Thanks, Chris. Hi, I'm Oindrila, the data scientist on the team, and I will be walking you through the exploratory data analysis and the modeling methodology. As my good colleague Chris explained in the previous pages, that a square root transformation was applied to the normalized scores in order to obtain a distribution that better represented the theoretical distribution of quality in the films. In our initial iteration, we had about 622 Netflix-only movies. As you can see, the distribution is slightly heavier right-tailed, as it did not have a similar proportion of positive and negative reviews. Thus, for our final iteration, we chose to expand the scope to 1003 movies, which had a better distribution. The graph on the extreme right-hand side depicts somewhat of a normal distribution, with the range of the score between 0 to 1, lowest to highest in quality, and mean and median of the score within 0.5. We reviewed the quality of 1003 movies with regards to various features. For the purpose of this meeting, we will walk you through few of the features that are extremely important to us. 84% of the data included English-only titles. There was a much smaller representation, 3 to 4%, from other languages like French, Spanish, and German. Among the top 5 languages by the title count, the movie quality score was the lowest for Hindi language movies, while highest for Spanish language movies. However, as we can see in the chart, there was not much difference in the quality of movies between the top 3, which is French, German, and Spanish. We also reviewed the top 10 movie distributors by volume. Our data was designed in such a way that more representation was there from Netflix movies, which is 28%. It is important to note, and is of potential concern for Netflix, that its average quality ranks several places behind Amazon Studios, one of its main rivals. We also reviewed the distribution of film quality score based on movie runtime. If I may draw your attention to the left-hand side graphic, you can clearly see how the movie quality score increases with the increase in movie length, indicating that it is one of the most important features that impact quality. The cornermost point on the top right is the movie Irishman, which is one of the most critically acclaimed movies of 2019. Analyzing genre was a challenge because films cross genres. Throughout the dataset, only 16% of the movies had a single genre listed. 25% had two genres, 29% had three, while the remaining 30% had more than three. Overall, dramas had the highest average quality score, averaging at about 0.4. The top of the drama's violent plot is represented by Roma, which has a score of 1, while the bottom is represented by God Not Dead, a Light in the Darkness movie, which has a score of 0.05. Comedies as well as romance proved to be low-hanging fruits and showed the lowest average score. Adding comedy to drama, dramedies improved the comedy film's reception marginally, and further adding it to romance also slightly elevated the performance of this genre. Finally, we also wanted to understand how the cast, actors, directors, as well as their past nominations impact the overall movie quality. When we reviewed the top 25%, which we are predicting in our model against the rest, which is the bottom 75%, we noticed a clear demarcation in the quality of the scores. We also noticed that this was primarily driven by the directors, who are also writers, commonly known as authors of the film. So, our objective was to present Netflix with a model that predicts the film's quality using those features that we just spoke about. Like most model development process, we followed an iterative methodology that was agile given our strict timeline. All our modeling was done on Google Colab, leveraging various libraries on Python. Post the feature transformation stage, and we got into the feature engineering, and we were left with 100 variables. Since some of them were highly correlated, we decided to use multi-collinearity check enabled by variance inflation factor to avoid model overfitting. We set a threshold on this to arrive at the list of features that would be more deterministic. Our predicted class was only 25%, and we were running into an issue of class imbalance. Thus, we went for an oversampling approach of the minority class. Throughout this build process, we reviewed several tree-based ensemble methods that fit this kind of imbalanced data really well. Several models were tested, tried, and built, and we finalized on the best performing model, which was our light GBM classifier model. Tree-based models are often regarded as black box, and it is often difficult for the business to implement them. So thus, we wanted to add explainability to our model. We leverage SHAP, which is commonly known as Shapley additive explanations, and the values associated with the plots of each feature's importance, their direction as well as magnitude, have also been defined and illustrated in our model output. This has helped make the model output more meaningful from a consumption purpose. Finally, the output of the model has been put into a Tableau dashboard for the marketers and the individual researcher teams to consume and educate themselves. As I mentioned, the light GBM classifier model was the best performing model. We tried tuning several hyperparameters associated with this, such as the number of leaves, the number of boosted trees, maximum depth, regularization, etc. The model with the highest performance was the one with 500 trees, 60 leaves, ratio to column while constructing the tree was around 0.6, with L1 regularization to avoid any overfitting. This model showcased the highest recall of 0.84 and precision of 0.82 and is an improvement from our baseline model. Our objective was to predict true high quality movies and not spend resources on the rest, which is the bottom 75%. With this model, we were able to better identify these true positives and seek a higher balance between precision and recall without impacting the model performance. I will be passing it off to Charles to speak more about the key insights of the model. Thank you.
Model output key findings. Using the light gradient boosted machine model, a Netflix executive could predict if a film's quality score would fall within the top quartile of film scores, our metric of success, with an 82% precision. While 16% of the predicted hits would end up underperforming, the model's recall score was a corresponding 84%. Insights regarding the film's quality were also gleaned from this analysis, some obvious, others not so obvious. To this effort, we used a Shapley additive explanations analytic to help visualize the magnitude each feature had in predicting the target and in which direction. The SHAP confirmed earlier findings that runtime and writer quality had a significant positive impact on the film's quality. Longer films tended to do well with critics. Possible theories for this was that these movies have more time for world building and plot development, or that studios are more likely to greenlight a longer film if they believe it's going to be well received. The influence of high-quality writing emphasized that the creative force behind the storytelling will be at the core of a film's quality. How that vision is realized by the cast and crew was comparatively less telling. Features like release month, actor, and director quality in positive and negative fashions. Movies released in the fourth quarter of the year tend to be rated better as studios release their best movies close to award season deadlines. Other insights we were able to draw from the model were work from auteurs or writer-directors tend to be well received by critics. Dramedies hit well with critics, showing that they do indeed appreciate humor. And adults like movies made for adults. Film ratings affected critical reactions, suggesting the movie with adult themes are more likely to be praised by critics.
The exploratory tool is designed for management and decision makers to assist in the process of delivering high-quality Netflix original movies. The dashboard contains all elements that have been proven to impact a movie's critical success and illustrates all projects in recent years that were part of the modeling process. For instance, we can see elements such as top score genre combinations, top directors by quality and nominations. The same goes for top writers, top cast combinations, and lastly, movie rating details and preferable runtime and release months. For starters, the user has the option of selecting the desired quality score range and a primary genre. By selecting the desired quality score and primary genre, the tool will provide insights on the elements that worked well in the past. For instance, at this point, we're seeing all the projects on the dashboard, but if we were able to select drama, only projects that were involved in drama will be selected and be shown in the dashboard. We notice that nowadays most movies can be categorized with more than one genre combination. That is why the lower visual really shows what are the most commonly found combinations and how they tend to perform in each different scenario. After drama, the most commonly shown combination for genre, it's a combination of comedy and drama that we can see on the second bar on the screen. Now moving to top directors and top writers. The two bubble charts side by side portray the top directors and writers with proven success within the desired genre. The colors of the bubbles reflect the average movie quality score, and the size of the bubbles indicate the amount of Academy nominations. In both cases, the directors and writers with the top quality scores are shown in red. And for instance, for top writers, we can see that clearly Joel Cohen is the writer with the top and highest quality score. Moving on to top cast by quality. The top cast by quality score shows the top combination of actors that have produced the best critically acclaimed content in recent years. And finally, at the lower part of the dashboard, we can find the movie rating details and runtime and release month. On the left, we can see the reasons why past movies have been given a restricted mature audience rating. This helps the user understand how these elements have performed with critics in the past. And finally, we have runtime and release month by quality. These last visuals help identify the preferable movie length and release months, and how these elements could impact the chances of the project's success. We expect this interactive tool to be very valuable for decision makers on a daily basis. Just in case, we have provided both the full desktop version, which is the one recently shown, and in addition to that, a mobile app-friendly version.
Recommendations for the way ahead. Our analysis suggests Netflix may be underinvesting in films with comedic elements as well as foreign films, given that both categories were correlated with quality in the larger data set inclusive of all film studios, but not the Netflix data set. This suggests that Netflix has overlooked such films, or that it has not yet cracked the code to producing successful movies from these genres. This opportunity should be investigated. Regarding further advantageous uses of predictive modeling, we advise the application of sentiment analysis to the screenplays of each film. This could yield invaluable insights into additional topics and emotions at a more nuanced level and be even more predictive of critical success and quality. As always, Entertainment Insights stands ready to assist you in uncovering and leveraging data-driven, actionable insights and further enhancing your modeling efforts to ensure that Netflix has the opportunity to stay ahead of the competition and securely hold on to the high ground in the streaming video on demand industry. Thank you